All right, you think. So anyway, this is Hikari, if you don't know him. Not only does he have like the schwankest, spikiest hair you've ever seen, but he's also damn smart. How's that for an introduction?
Sounds good. Hey, everybody. Thanks for the introduction. Yeah, so my real name is David Hulton. Some people here like to call me Hikari. I'm the chairman for Toorcon and also do lots of security R&D with FPGAs and stuff. So I've already talked about some of the things I'm going to be covering today. There's actually a lot of things here, and I'm going to skim through as much as I can. First of all, how many people here have seen me talk before? Anybody? Okay, a few people. How many people here know what FPGAs are? Yes. Sweet, okay. So I'm just going to skim through all stuff. As you can see, there's a lot of new things I'm going to be demoing, and I'll probably skim through a lot of the explanations just so I can get to the demos. So first of all, FPGAs are a bunch of different gates that you can just hook together however you want. It's actually a chip, and you can design any sort of chip design, upload it to the chip, and it'll function like that chip. So you can design your own processor, you can design your own graphics accelerator. In my case, I'm designing basically a chip that cracks crypto and uploading it to these chips that we have and cracking crypto with it. And when you have dedicated hardware like that, you can do things a lot faster. So this is kind of what a chip looks like. This is a Vertex 4 LX25. And it has different things like input-output pins, slices, which are general purpose sort of areas of the chip that you can configure however you like. There's DCMs, which are clock multipliers that let you change clock frequencies and stuff. Kind of like the jumpers on the old school motherboards to set your speed. Block RAMs, which are kind of like cache. They're storage elements inside the chip. There's these DSP slices that are used for doing multiplies and additions and really high-speed sort of math calculations. And then all the different sort of components in here you can connect together with the programmable routing matrix, which lets you connect anything with anything else on the whole chip, which is really what makes the whole thing work properly. So first of all, I'm going to be covering this program called Airbase. Anybody heard of that? Airbase? Yeah? Okay, a couple people. So Airbase is actually written by Johnny Cash, and it's a re-implementation of AirCrack and also like a brute force web cracker that actually supports distributed network cracking, kind of like distributed.net, where you basically have a server and a bunch of clients out there, and you can feed out jobs to crack web by brute force. So it also contains a bunch of different tools that are for manipulating web file captures and stuff. So you can check all this stuff out by yourself. But essentially, it's all the same tools that you see with AirCrack and with any sort of standard web cracker. This is what JC AirCrack looks like. It has lots of cool ASCII effects and stuff. This is JC Web Crack. There's a daemon in the client. And we also have a Pico client, which is our FPGA accelerated client. And this is kind of what a screenshot looks like. I'll be doing a real demo of this later. And yeah, basically the daemon has clients that connect to it. With our Pico client, we just attach an FPGA to it and offload the web cracking to one of our cards. And there's lots of different ways that you can do this. With JC AirCrack, one thing that Johnny actually did was he has this library that does all the RC4 cracking stuff, and he actually implemented Pico support. And so as long as you use this library, it'll just automatically use the Pico card and or automatically use what machines you have and stuff. Oh, Pico card is one of our FPGA cards that we design. But you can take any sort of FPGA development board if you like and use that. Here's actually one of them I can show you. Verilog? Yeah. So this is our Express card. It's a module 34 size Express card that's plugged into this laptop. We've also got a compact flash one and a card bus one. So basically, Airware is made so you can, just plug in arbitrary hardware, accelerate your algorithms, and just use it and not have to worry about, the actual thing that's doing the computation. And actually, Johnny was saying that HDM threw together some RC4 acceleration for the PS3, so it actually uses the hardware units on there to do stuff. I'll show you some performance numbers on that later. So this is kind of the whole tool suite. You can look at it more later if you like. Web cracking basics. All you do is you sniff a packet. The first few bytes are predictable, so you XOR that to get the actual output of RC4 for a given key. And then from there, it's basically just taking the output of RC4 and reversing it back into the key. So my design actually uses either 32 or 48 custom RC4 cores. And so I have a ton of little RC4 cores running on the chip, and they just do RC4 really fast and try to reverse that back. So essentially, your input is this K over here in RC4. I don't know if you can see my pointer. And then the output is the PRGA, and so it's just reversing that back across. So yeah, it's a total brute force attack for this implementation, and then also JC Aircrack does that attack for doing the statistical sort of stuff. And yeah, essentially, we have a key generator where you tell it, okay, start at this key and end at this key. It starts sending out keys to the RC4 cores, gets the PRGA back from them, and then checks to see if it's the right value or not. And so it gets a bunch of PRGA back, and then eventually it actually finds a matching PRGA and says, okay, here's the actual key that corresponds to that. So it's fairly straightforward. One small optimization that I do is in RC4, there's this whole initialization phase that takes a really long time. And that can actually be done in parallel with all the other operations. So that's one optimization. You can look at the code later if you want to see exactly how all that works. Then performance numbers with this is with JC Webcrack, and typically like just running RC4 on a machine, you can get maybe about 300,000 crypts per second. With the PS3 client that HDM threw together, using all the 6 SPUs, you can get about 1.4 million per second. And with our little compact flash card, you can get about 12 million per second. And we also sell clusters of them with like 15 that'll get you about 180 million. And how this relates to actually cracking a 40-bit key is that on a PC it takes you about 42 days. With one of our cards in a laptop, you can do it in about 24 hours, so a little over a day. And then if you have a cluster of multiple ones, that brings the time down quite a bit. And with the PS3, it takes about 8.8 days to break 40-bit.
Hey David, are those numbers 100% of the key space or 50% of the key space?
That's 100%, the full 40 bits. So yeah, like if you're talking about like birthday paradox sort of stuff, then it'd be maybe about half that. So Pico Webcrack is basically the JC Webcrack D plus Pico cards and some cool matrix effects I'll be demoing in a little bit. And also a new release that Johnny just threw together is JC Aircrack with Pico support, so I'll be demoing that as well. See if this switches over. Yeah, okay, cool. All this stuff you can download off of opencyphers.org, by the way. So this is the web brute force. I just threw together some scripts here, typing with one hand. Yeah. This is a pretty small key, so won't take too long here. So this is actually starting up the daemon right now. Then it'll start up some Pico clients. Because this actually has 3 separate cores that it's talking to that each have 16 RC4 cores, there are 3 different instances running here. And it actually just found the key on one of them, which is a pretty simple key. But that's going at about 9 to 12 million crypts per second right there, and it just found it. I don't have too much time, so I did a pretty short demo for this one. And now I'm going to show you the aircrack stuff real quick. So here's, I'll show it to you without the FPGA support. So this is running, this is using the FMS. Oh, can you see everything? I lose video? Oh, there we go. Okay. So right now it's doing the FMS attack with just JC Aircrack, and it's chugging along. This will probably take a little while. So as you can see, it's doing maybe about 1 chunk per second, maybe a couple chunks per second. And I'll just cancel it now because I know it's going to take a while here. And so now with the FPGA, now it's doing about, how many chunks per second? Maybe 30 or 50 or something? Or, yeah, so it's already gone through, 733 chunks, and the last time it took maybe about 10 or 15 seconds to go through, 50 or 60. And there's some cool animations too, so. Okay, there we go. So it's basically just like aircrack, but now you can accelerate brute forcing the last bytes with an FPGA. So let's switch back over. Now I'm going to switch over to this other laptop because all my other demos are going to be done in Windows. Some new support I threw together. Hopefully this Vista laptop will work. It actually helps my demos look a little bit better because it's so slow that all the software runs slower. Let's see here. Wait. Mirror displays. There we go. Okay. Hopefully my slides will work here. Try restarting this. Does it have a stupid thing? Yeah. Okay. All right. There we go. Cool. Okay, so I'm going to skim through the WPA stuff. Essentially, for added security with WPA, when you actually type in your passphrase in Windows to log in, to your WPA access point, it actually hashes it with PBKDF2, and then it actually uses that as your key for authenticating on the network. And the reason for doing this is because they just wanted to have a really good secure transform from your password into an actual, secure key. And PBKDF2 essentially just it runs SHA-1 about 4,000 times, and so it takes a really long amount of time to actually compute this PMK value from your passphrase. And so their hope was that because it takes so long to do that, every time you try to convert over a real passphrase to a PMK value, it takes forever, and so somebody attacking it, would take a really long time to actually crack. So essentially, all I do is I just accelerate the PBKDF2 phase using 8 SHA-1 cores, and essentially this is the performance comparison that I get. With Cowpatty on pretty top of the end P4 Intel Core Duo, you get about 60 or 70 per second. On one of our FPGAs, like our Compact Flash one, you get about 430 per second. And with Aircrack, you get some optimizations, maybe about 100 per second on a PC.